Thank you very much, and welcome everybody to this talk about microservices on OSGi. I borrowed that title from various talks in the last few years. The best title was about 4 years ago by Neil Bartlett, who took that title and had a subline that said how to choose a presentation title that is taken in every conference. But I want to make this talk a little bit different, but I come to that shortly. Just a short introduction. My name is Dirk Faut. I'm software architect at Robert Bosch, and I'm an Eclipse committer, so you will see a lot of Eclipse technology. And with me is Peter Kirchner, a longtime colleague in several projects, developer, architect, OSS, OSGi, and Eclipse enthusiast. Yes, we're giving this talk together. Well, mostly I will do this because the second part is broken, but I'll explain that in a few minutes. So what's the motivation? Well, microservices are still one of the current hype topics. So still the microservices architecture is all around. Wherever you go, you find talks and tutorials about that. A lot of people are actually doing already microservices with different approaches. So we have Spring Boot and Lagom and various technologies. But what some or most of the people don't know is that OSGi has a mature service design. And the service design or the service specification is in the core specification in R6. You can find this in chapter 5, the service layer. And declarative services in the compendium R6, which is the de facto standard for using and creating services in OSGi. And also, there are specifications for remote or distributed services. So we have in the compendium chapter 100 remote services specified, and the remote service admin service in chapter 122. So if you're reading about services and microservices in OSGi, and if you come across the en route project, there's even a little joke that says, well, OSGi is even more advanced than microservices because we can do nano services, because our services are even smaller that we can distribute. And the last thing is, there are several talks about OSGi and microservices and remote services. I listened to a lot of them. There are also very good ones, but most of these talks are more on the architecture part. So they're talking about microservices architecture, and then they're going, then at the middle, a short technical point, then a demo that is sophisticated, and then you're free to work on this and need to find out all the information yourself. How does this work? So I came across this myself. I listened to those talks. And then I wanted to play around with it and didn't know where to start. What are all these specifications, all the entities, how they play together. And this is my way of creating a getting started to help people come into the technology. Short overview. I hope this picture is known to everybody here. It's the typical service architecture picture in OSGi. Who does not know this?
Isn't it backwards?
Well, that's from the specification, right?
So the publisher would normally have the service arrow pointing at them.
Yeah, okay. Well, he's probably more right than me, but I copied this from the specification, so I hope I got it right, but I might be wrong. But mainly it says there's a bundle A and it publishes the service, and we have a bundle B that is getting the service, and it listens for changes to the service. So if a new service comes up, the service goes down, it gets informed. That's a dynamic, the dynamics in OSGi. But it does not say anything about boundaries. It just says there are two bundles and they share a service. Now, if we think about remote services, we might have on the one side a lot of bundles that are providing services. They're providing them to somewhere in a cloud, because that's also one of the hype words we're facing. And on the other side, we have a lot of other bundles that are consuming them. We don't know where they are. So having that in mind, I was reading the remote services specification, where I find this picture, which is quite similar to what I just pointed out. So we have a service consumer, we have a producer, and somewhere in the middle there's a distribution provider. And well, yeah, there are endpoints so they can communicate. The one exports, the one imports. Okay, that's easy to understand, and we just need to talk about some terminology. So there's the remote service, or also known as distributed service. That's an OSGi service that is available across container boundaries. Nothing more, nothing less until now. We have the distribution provider, which was more kind of a hassle to understand. So what is a distribution provider? What is it actually doing? And it has four major topics to do. It exports services and it imports services via endpoints. That's the main purpose from the remote services specification. It manages the policies around the topology, so how these endpoints are find and distributed, and it discovers also remote services. That's part of the distribution provider. If you only read those two specifications, remote services and remote service admin by itself, it's not very clear. At least it was not for me. And the third point here are endpoints. Well, that's the communication access mechanism between the remote services. So a protocol that these endpoints can communicate, that you can call a remote service and find them. And the topology is the mapping between services, endpoints, and their communication characteristics. Now, I'm saying this, or I pointed out this, because when we're coming to the remote service admin, all these topics come again. And if you don't know them before, you'll get in a hassle. At least that was for me. I'm always talking about my experience the last weeks and months. So that's pretty easy so far, huh? Isn't it? Now I went over to the more complicated specification, remote service admin. And there you get this picture. And this is, you find this in a lot of other specifications or documentations. Always you find this, and that's the implementation more, because now you have three more entities here that are important. You have the discovery, the topology manager, and the remote service admin. And in between, you have a network cluster, endpoint event listeners, and the remote service admin listener. But I don't want to go in detail to them. That's more important when you implement the remote service admin specification. But important is, and you don't see the red. Okay, these highlightings here are red. I would like to explain those three reds. You don't see red. So the first thing is the remote service admin. It took me quite a while and find the one sentence in the specification to understand this. It's the passive distribution provider implementation. And it's passive because it provides the mechanism to import and export services, but it does not do anything itself. It needs to be triggered by someone. The someone who is triggering it is the topology manager. Now, the topology manager provides the policy for importing and exporting, and it does this via the remote service admin. And it implements the topology using the remote service admin. And the discovery discovers and announces endpoint descriptions via discovery protocols. We come to this shortly. And an endpoint description is, well, it's a property. It's a collection of properties to describe an endpoint. So how you can find it, what's the name, and all that. Now with this information, I came to this picture, and probably, I'm not sure if this is 100% correct or if some OSGi experts are now throwing stones at me, but it helped me to get a better understanding. So we have the service producer, and from the first picture, there's a distribution provider, and the remote service admin specification is the combination of the topology manager, the remote service admin, and the discovery. That means as a service producer, I'm exporting a service. I'm marking a service to be exported. The topology manager gets the information that a service is exported from the specification picture, does this via listeners and so on, but implementation detail, we don't care about that now. And then the topology manager instructs the remote service admin to export an endpoint. And once the endpoint is created, so the service is exported, it informs the discovery about this. So the discovery is announcing this exported service. Am I right until now?
So it all looks good, but I wouldn't call it distribution provider because that's the official name for the thing that we call remote service admin.
Okay. All right. I will update for my blog post, but okay. Thanks for the feedback. Then this is wrong here also, but it's the other side, right? So there's an endpoint that's somewhere in the web. The discovery finds this because it shares the same topology. So there's an endpoint available. I'm discovering it. We have again a listener mechanism in the background. So the topology manager learns from the discovery. There's an endpoint. You need to do something with it. And the topology manager then instructs the remote service admin to import it. Importing means creating a proxy, registering that proxy object in the service registry, and then every call is remotely executed. That's so the overview over it. And that picture, although distribution provider might be not correct here, it helped me a lot for the complete understanding. Now, how does the implementation look like? That's interesting for us as developers. Well, we're using Declarative Services, and then it's pretty easy because okay, it's again not highlighted. This beamer is not very good. Okay, so highlighted should be these two properties, service exported interface and service exported configs, which mark the service to be exported. Now, these two properties explained in short. So the first one is required to mark a service for the export. And the value says what you're exporting. With the star, every service interface is exported. That's pretty simple for the service I just showed because it just has one interface. So shortcut for this. But typically, you also have a service that implements more interfaces, like a consumer interface and a producer interface. And you don't want to publish your producer interface to the world. You only want to announce the consumer interface to the world. And service exported configs tells which configuration type is used, so what topology should be below. I read from the specification that this property is optional. And I tested this, at least locally, without this and only having one distribution provider available, my service is still exported. So the runtime is choosing. Why I'm mentioning this is coming at the end. Just to mention here, there are several implementations for distribution providers. I took the two biggest I know. That's the ECF project. I just have chosen the generic provider also for the example, because I wanted to make it as simple as possible. So this is from the Eclipse world, and we also have Apache CXF, who is providing this via web service, who is providing distribution providers for web services or via REST services. And the list of implementations, because that's a good way to start, to know what implementations of remote service admin there are. And there is the Eclipse Communication Framework, Apache Aries RSA, Mdatu, although I'm not sure how active Mdatu is currently. I don't know, haven't seen anything, and the last update was 2015 or 13, I'm not sure. We have Perimus RSA, and here are some colleagues from Perimus, so if you have questions about that, feel free to ask them yourself. And we have Apache CXF, which is providing distribution providers for ARIS RSA. Funny fact is that the Eclipse communication framework has a wrapper implementation that is then operating on Apache CXF. Funny, but that would be also working. Okay, at this point, so I got the basic understanding of how the remote services work together and how these specifications work together. From the implementation, it was quite easy to, well, okay, I need to add 2 properties and then I export a service. And then OSGi hit me very hard. Because what bundles do I need in my runtime? This is something I rarely find in any tutorial. What bundles do you actually need to make your example work? I was also attending another talk about microservices who just showed in his Eclipse IDE, oh, here is the list of 50 bundles, and now Eclipse Remote Services are working. And I was sitting there and was wondering what bundles and why there are 50 of them. Now I know, but okay. So here's the list of the basic OSGi stuff I added. So we have our application bundles. I have an API bundle for the service interfaces and an implementation, the uppercase. I added the OSGi console. Not sure if you will do this in a productive way, but it's good for debugging and getting started. And as you can see, I used Equinox, which hit me hard the second time, but I'll come to that in a moment. So we have Equinox OSGi implementation, the Equinox service interfaces, common runtime that is needed. The EventAdmin is added because the specification says when a remote service is exported, an event needs to be fired so you can react on that. The util bundle, and funny, or maybe you don't know this yet, Apache Felix Declarative Services are now the declarative service implementation in Eclipse Oxygen. So in Eclipse, we decided to deprecate Equinox DS because it was not maintained for years, and to integrate Apache Felix DS as a reference implementation into the Equinox runtime also, which I like very much. Org Eclipse OSGi util is, for me, also very interesting. It contains the OSGi Promises API that is used by DS. So Equinox decided to bundle them in another bundle. So you need these 2 now if you want to do declarative services with Equinox. Okay, we could run this application. It would be plain OSGi. We would have a service, and if we have a command bundle, we could talk to our service. That's a pretty standard getting started with DS stuff. And now I want to do ECF with generic providers. So I want to export my service as a remote service. And now I have this list of bundles. If you go through all the documentation you can find, and the ECF framework did a lot of, so there is a good documentation, but stepping through it is quite hard. And getting this resolved manually, because some of them do not have dependencies to each other. That's more formal dependency and not by classes. It was hard to gather this information. Okay, I found some examples and could then write down this list, what I have here. And then the next thing came to my mind, what can I exchange to use another provider? Because there are different distribution providers available. I wanted to start with a generic provider because it's easy. But maybe at a later time I want to use a REST service API or a REST-based topology. What would I need to change? And again, it's getting red, so you don't see this. It's these 3. The generic provider here, together with the generic provider remote services support, and you can exchange the discovery. Well, most of the discovery that I found are always based on zeroconf or bonjour, if there's this better known to you. So we can change how discovery works, and we can change how we provide, so what the topology is. With ECF, That's why I said initially I'm from the Eclipse world, so I'm talking about ECF. They have two implementations of discovery, one with JMDNS, so the zero-conf bonjour, or JSLP, and Zookeeper, is that the Zookeeper is an additional? Okay, there's also, you can also use Zookeeper. But it's, I don't see the implementation in ECF. That's in Apache, right? And we have some distribution providers. So the generic one, you need these two bundles. The most of the examples you find are with our OSGi. So you need these two bundles. Or you can use the Apache CXF JAX-RS implementation for ECF. Quite long, but there you need these bundles. And well, if you use another implementation, you will have additional dependencies. So when you're using Apache CXF, then you probably will need Java X Servlet additionally. You need a web server like Jetty. So there are coming more dependencies, which is actually the fact why I wanted to use this ECF generic provider to focus on what's going on with remote services. And here are, again, the links to the distribution providers. Now, I also said I had trouble with getting things started. And yeah, Equinox was hitting me very hard. Because Equinox has a special handling when it comes to bundle activation. In Felix, it's nowadays common practice that every bundle is auto-started by the launcher. At least you can configure this, and it's the default configuration because the lazy activation of any logic is done on the DS component side. So bundles can be activated without cost, and if I need lazy activation, I do this in my declarative service. Now, Equinox still has this old style feeling, so we are controlling lazy activation on the bundle level. That means not every bundle is automatically started. We delay the bundle activation. Now, bundles get activated when someone requests something from that bundle, which is in 90% of the cases pretty fine, but not for DS, for example, because who's telling DS that it needs to be started? No one's there to say, DS, you need to run, or EventAdmin, you need to run. Well, if you need the EventAdmin interface, it would work, but that is located in Equinox in another bundle and not in the EventAdmin bundle. So nobody starts the EventAdmin. I know that from the past, but I didn't know which bundles from ECF I need to start to make remote services work. So, well, after searching and fiddling around a bit, I found out that these three bundles need to be started at the beginning to make remote services work. So I'm creating a launch configuration, getting them started, and then I had additional problems. I tried to use a product file because that's typical when you're working with Equinox, and suddenly I have two additional dependencies in my application that I needed to add. It simply refused to start, so we need Equinox app and Equinox registry. That's why I currently favor more creating manual launch configurations and exporting my stuff itself to make the smallest possible runtime, which is interesting for embedded development. And then I had another issue that came up, well, also with the auto-starting of bundles, or not auto-starting of bundles. In the demo I have an Eclipse RCP application, and I'm using the newly introduced add service annotation, which provides a similar injection behavior than with the OSGi IDS at reference. But when using the remote services, I had the problem that this interface bundle was not loaded once the remote service admin was started. So the remote service admin started. By reflection, it found out I need to load the interface, but the interface bundle was not loaded yet because of the lazy loading stuff. So I got a class not found exception. Okay, so I needed to add a default start level that's lower than 4. And I also tested this with a low-level OSGi API. So I called the service tracker to find it, so I didn't use any injection mechanism. And then the UI activation stuff hit me because UI bundles are typically never activated. That's how Equinox and Eclipse RCP is working. If you come across this, yeah. This did cost me half a day to find out why things are not working in my application. Okay, most of the time done. So I will come now to the conclusion. Then I try to show you a demo, but that demo does only work halfway, and the conclusion has that point. So first of all, when you know what to do, the implementation of a remote service is quite easy. You just need to add the property and things are working out. And it's probably getting even easier with R7, which Tim Ward is showing tomorrow in his talk. I'm pretty curious about that. So I hope it's getting much easier, and, well, thumbs up. It's complicated at runtime definition because finding out which bundles you need to package into your runtime, that took a while. And it was also not very helpful which one needs to be started, and yeah, it was pretty hard for me. It did cost some time. And on the DevOps side, it's getting even more complicated. This part is even available in the remote services spec in OSGi, the fallacies of distributed computing. And these fallacies hit us now. We tested yesterday downstairs with the Ethernet cables, and our demo worked pretty fine. We did try this today here with the local hub, so same setup, but without the Ethernet cable from downstairs, of course. And we don't get the demo running between those two laptops. I have totally no clue what's wrong now, and we don't have the time to find out. But I can show you the local implementation. We also need to discuss about service interface evolution. So if it's, in OSGi, it's pretty clear that when you increase or add methods to a service interface, you increase the semantic versioning. So you have a dependency. So that's pretty clear between a consumer and a producer. But when you compare this with the REST-based services, the consumer does not have to change when the producer changes. I'm not sure how this works in OSGi. Do you have, is this a problem or is this easy to solve?
It's not easy to solve.
Okay.
But typically you put into the endpoint description the version of the interface that's being implemented, and then you provide. So I was interested to hear you say that it was trying to eagerly load the class of the service interface, because it's normally done reflectively with a proxy built on demand for the person who's using it. So you can use it across lots of different class spaces, and you basically give them something that matches up to their version, and if they're a too high a version, you just make sure you throw the relevant exception when they start running all the methods. Okay, I'm pretty happy that you're here. Thank you. That was something I was not really aware of from now, but now I'm aware of. Thank you very much. So I didn't cover that yet because I just wanted to help people to get started, and then you come across these issues, for sure. And then you need a solution for this. And one thing that, while looking at this, confused me a bit was that the developer specifies the topology in the component properties by saying, okay, I use ECF generic server, or I use Orc Apache CXF. No, it's not a problem. So you just shouldn't do that.
Yeah, okay.
You just shouldn't specify that property. It's a bad thing to do. You only do it if you really need a specific provider for some reason.
Okay, thank you very much, because that was also my understanding. But every tutorial you find, every getting started is providing that information. And then you're sitting there and thinking, okay, and now I want to change the topology. Typical, and that's what I said, if you don't provide that property, then the runtime will decide which topology to use. And if you only have one available, it will choose that. So yeah, don't follow all the tutorials that specify the topology manually, because it will hit you later on in the development, in the deployment. Okay, demo. This was our idea. We have an RCP application which has a local service provider. We have on the, a local service provider. We have on another PC a service provider. That should be him. And we wanted a Raspberry Pi with a service provider. And then show you in the Eclipse IDE how the import of all these services are working. Well, unfortunately, the fallacies of distributed computing hit us. But at least I can show, okay. This, so here we have the service provider. Is it readable or? Okay, and now it doesn't work anymore. Okay, it worked when I tested. Okay, but it's not very sophisticated. We're exporting interfaces and ECF generic server, and we have a runtime configuration, and I cannot increase that anyhow. With all the bundles I need to auto start. And I have the consumer inverter part, and this is what I mentioned in the presentation, the add service annotation we introduced with Eclipse Oxygen, which allows you to inject services dynamically into the RCP in an E4 view. This did not work before without the, so if you only use add inject, you get one service, and that will never change at runtime. With the add service annotation, we're dynamic also inside this. So if we start now my UI, then I will notice that it is already running. And I can see that only one modifier is registered. And if I start my uppercase provider, I registered the listener here also that is telling me that an endpoint was exported. So for debugging, this is very helpful. And we can see there's an export registration from the provider side. And on the consumer side, I can see an import registration was discovered. So if I now call this again, the second service that is coming, well, remotely because it was another VM, but on the same PC, was discovered dynamically. The showcase would have also shown on his MacBook providing another service and on the Raspberry Pi, but yeah, fallacies of distributed computing. I'm sorry for that. Now, that also means I'm at the end because the presentation, the demo did not work very well. But yeah, references. I'm writing blog posts about declarative services and OSGi, and I thought they were pretty good. At least I use them for myself as a reference when I can't remember. And once someone, yeah, he told me the best about my blog posts are the references at the end, so I will follow this and give you the references. As I initially said, I have listened to several of these microservices and OSGi talks. One, I think it's from 2013, Neil Bartlett, who already gave this a similar talk. No, he gave the talk more on a global scale. Achim Nierbeck, who's showing how to run this with Apache Karaf. Christian Schneider gave his talk last year here at the Eclipse or OSGi community event, and it's also recorded. Yeah, nice example. Graham Charters also gave a talk last year on this topic. So there you get the basic informations. And these two presentations are actually interesting because of the example they are giving. So Wim Youngman, I think it was 2013 when he did this talk, he had a setup with a Raspberry Pi running Eclipse Equinox, some Nebula visualization widgets, and he was cooking an egg. So he had some IoT setup, so he could control via the PC how to warm the egg via remote service. And Christoph Keimel last year gave a pretty interesting talk about live escape games, where you need to disarm a bomb, a virtual bomb, via Raspberry Pi. So he also works with remote services and everything. So these things are pretty interesting to look at, to see real world cases where remote services are used. Yes, and that means I'm done. Early, please evaluate the session and give me feedback what I have done wrong today, so I can make it better the next time. I hope you enjoyed it, and I hope I could help you in getting started with remote services on OSGi. I'm also planning to write a blog post on this with some more details for the future. And if you're interested in the topic, attend Tim Ward's talk tomorrow on remote services with R7.
Microservices.
Okay, on microservices with OSGi R7, which is, as far as I understood, will get a lot easier with R7. Yeah, okay. I will attend your talk. Definitely.
So are there any questions for the
A good part of that, I find the summary pretty good for somebody to start with OSGi or the OSGi. But why you call your talk microservices with OSGi? I did not hear you talk about microservices for the whole talk except that.
Okay. I could also name it nano services. That was the topic last year where I gave the tutorial. In the end, every service that you're making remotely available is a microservice, because it's a small service that you're distributing. What else is microservice? Yeah. You're perfectly right.
So you think of REST-based microservices? Sorry? Are you thinking REST-based microservices?
Yeah, that's how we communicate to the ends, but can you just not all OSGi services to say that they are all microservices? Does it bring all the properties of microservices automatically with it? Deployment, for example, if you want to deploy your microservice here with OSGi, will you deploy for every microservice the OSGi layer with it? That it's self-contained?
Yeah, okay, understand.
Platform, then you say your service.
So you can have, you do both. Yeah, and you can have a heterogeneous environment where you've got some non-OSGi services and OSGi services and all wired together in sort of a heterogeneous environment.
Of course, these are the questions that I think to get the answer for when the microservice.
Yeah.
So it's worth thinking about with the references section, looking back at Neil's talk. So he actually goes through the things that make you a microservice. And there's pretty much the only one that doesn't apply to OSGi services is process isolation. And actually, you don't always want process isolation, because process isolation adds overhead. And there are trade-offs. But they do have almost all of the characteristics of microservices as defined when talking about microservices.
One of the really cool things about OSGi microservices is you can co-locate them in the same way you have, and then you can break them out across the network with zero code change, which is something you can't do with REST-based microservices. You want to play in protocol, easy to co-locate. Any other questions?